So this video is going to be based on 21, 22, 23, 24 through 27 of our of the practice exam. So I'm going to take a graph. This is slightly different from the graph in the exam, but we're going to look at on what intervals is the function increasing, on what intervals is it decreasing, and we're going to estimate the local minimum and maximum. Okay, so clearly we can see as we want to think about as we're increasing our input, so moving from the negatives toward the positive end, what is happening to our function? Well, as we move here, if we start, say, negative infinity, looks like we're way down toward negative infinity, and then we rise up, so we're increasing until we get to an input value of about, say, -3, and then we're decreasing, and then here at an input of 2, we're increasing again. So we might write that as on the interval, say, negative infinity to -3 and 2 to infinity. Now, you can also use the infinity symbol, of course, but that's our increasing, right? And then, of course, decreasing, our function is decreasing in the in-between interval, so between -3 and 2. Now, oops, well, okay. So in this interval, one thing to note that we left our intervals open, assuming that this is the turning point at -3 and at 2. Those then at that point it's not increasing or decreasing, so we can simply say we can leave those points out, but up to those points. All right, then we want to estimate the local minimum. Okay, well for us, looks like the local minimum is at 2, and maybe it looks pretty close to -2. In our case, it's not actually exactly that, but that's pretty close. And then estimating the local maximum, looks like we're at -3, which is what we should expect, right? That our maximums and minimums are related to the edges of our increasing and decreasing range. And then it looks like 5. Okay. So we have those bits, and we can, if we want to zoom out of this. Now in the problem, of course, you can't change the graph, but you get to see that part of it. Okay, so that represents the increasing, decreasing, local max, local min, and we can kind of do that. Now this is the equation that we used for that situation, and you can actually see, if we're on this point is actually slightly higher than -2. But it said estimate, so we estimated. Okay, so in the next part we're looking at a piecewise function, and we're going to evaluate at a couple different places. So here we have a different piecewise function. So one thing that we can note is that we have kind of two pieces going on. One looks a lot like a chunk of an absolute value problem, and then the other looks like a constant, right? So no matter what input we put in for this part, we get out the same number, 5. So if I were looking for, say, f of 6, well, that's my input of 6. I'm going to get out 5, so I have a point at 6, 5. And if I say f of -1, for instance, so f of -1 is found here at 6, so f of -1 equals 6. Okay. So we can find those two pieces, and then it says write an equation. So if I wanted to write the equation, I'd need to think, well, this part's easy. in this case, if I talk about from x is equal to or greater than 3, for that section, I can just write 5, right? My function f of x is equal to 5 from 3 and including 3. Okay. Now for this, I have an absolute value, but I can see that it's been shifted from its original absolute value. It's been shifted to the right 2, and it's been shifted up 3. And we can also see that it's maintaining its, it hasn't been stretched or compressed or reflected at all. Because each time you move over 1, you move up 1. Okay. So then we would say, and it looks like it goes on forever in our case. So from negative infinity to 3, but not including 3, we have an absolute value that would be inside the absolute value sign. We should have x minus 2, and then outside of the absolute value we have a plus 3. And you can see that here, less than or equal to 3, and this. Now if you were putting this in piecewise function notation, you'd have the open curly bracket, the brace through here, and then they would both be called f of x.